So this is how I solved problem number 1 for homework A. The first thing I did was consider the initial value problem, and then I looked at this equation here. And the first thing I wanted to find was when y prime of t equals 0. And if you look at the equation, y prime of t equals 0 when y equals 0, when y minus 2 equals 0, which is at y equals 2, and when y minus 10 equals 0, which is at y equals 10. So we know that y prime of t equals 0 when y equals 0, 2, and 10. So the next thing I want to do is plot those lines on the xy chart I created here. So y equals 0 would just be the x-axis, y equals 2 would be about right here, and then y equals 10 would be somewhere up here. And to label, this up here would be y equals 10, this one is y equals 2, and this one is y equals 0. So I recreated my xy plane here, and the next thing we're going to do is plot points between the boundaries and above and below to see if they're positive or negative. This will tell us if the original function is increasing or decreasing, which will help us find the limit. So to start, we're going to pick any number up here. So a number that's greater than 10 would be 11. And we're going to plug it into this differential equation up here. So if we rewrite that, that gives us y prime of 11 equals 11 times 9 squared times 1 squared. This equals 891, which is a positive number. So I wrote up here that y equals 11 is positive. Next, we're going to test a number between 2 and 10, and we can pick 3. So y prime of 3 equals 3 times 1 squared times negative 7. And that equals negative 21, which of course is negative. And now I'm going to plot a point between 0 and 2. A number that would work nice is 1. So let me change that to red. So y prime of 1 equals 1 times negative 1 squared times negative 9, which comes out to negative 9, which again is negative. And finally, I'm going to plot a point that's less than 0, which could be negative 1. So y prime of negative 1 equals negative 1 times negative 3 squared times negative 11, which equals 99 and is a positive number. So since we plug these points into the derivative, it will tell us if the graph of y of t is increasing or decreasing. So above 10, we know it's positive. So the graph should look something like this for all the different solutions because it's increasing above 10. The plot we pointed between 2 and 10 was 3, which it says right here is negative. So we know that between 2 and 10, the graph must be decreasing. So it could look something like this. And between 0 and 2, we plotted 1, which is also negative. So that graph is going to look something like this. And then under 1 or under 0, we plotted negative 1, which is positive. So that graph is going to be increasing under y equals 0. So now that we have the graphs, we can easily solve problems A through D. So A says when C is equal to 8, which is going to be between 2 and 10. It says it wants the limit from negative infinity. So if we go between 2 and 10, 8 will be right around here. And as it goes to negative infinity, it's approaching y equals 10. So the limit equals 10. For part B, it says when c equals 1, c equals 1 between here, and it wants the limit as t is approaching infinity, so it's going in this direction. So as t is approaching infinity, the limit equals 0. For part C, it wants to find out what y of 10 equals when c equals 10. And if you look up here, when y of 0 equals c, that means y of 10, we have to look in the graph, and at y of 10, it equals 10. So when c equals 10, y of 10 also equals 10. And for part D, it wants to know the limit as yt approaches negative infinity when c equals 2. So if we go to 2 over here, and we look at what it approaches as it goes in the negative infinity direction, we see that it also approaches 2. So I believe that these are the answers to parts A through D for problem 1. I hope they're correct, and I hope my method makes sense. Thank you.